Hi everyone, this is Mrs. GA, and today we're going to learn about the properties of logarithms. Before we start, I'm going to have you guys try this quick warm-up, so please pause the video and give it a try on your own, and we'll check your answers in just a few moments. Okay, so go ahead and check here. Remember that logarithms define exponents, so this is essentially saying if 4 is the base and 64 is the result, what is the exponent? So the first one, it's 3. For the second one, if you have 1/2 to what power is 8, well, we can see that we do need it to be a negative exponent to cause that reciprocal, and then we cube it, so -3. Here, remember, this is a natural log, so the base is e, so e to what power is e? Well, it must be 1. And the last one is a common log, which is, of course, base 10, although we don't write it. So 10 to what power is 1 over 100? We know that we need it to be negative to get the reciprocal, and then we square it. All right, so now we're going to start talking about the properties of logarithms. So just remember for our logarithms, a few important things. The base must be positive, and it cannot be 1. So just keep that in mind. So our first definition-based properties, if you have a logarithm where the base and this value match, you can evaluate it to whatever that exponent might be. So sometimes you'll see an exponent there, or maybe it will just be 1. So again, if the base and this number match, it can simplify to whatever is left over in the exponent. Here, if you have log base b of 1, any base logarithm of 1 will always be 0 because b to the power of 0 is 1. And last, if you have log base b of b, again, if your base and this number match, the exponent must be 1, so it's equal to 1. So these are things that you've actually already been using when you evaluate, but we're just kind of spelling them out as properties. The next one are the product properties of logarithms. So notice it says product, which means multiplication. So if you have multiplication within a logarithm like this, we can actually expand it out into two separate logarithms using a sum. So the log base b of m times n can be rewritten as the log base b of m plus the log base b of n. So be really careful here. A really common mistake I see is maybe people say that the log base b of m times n equals the log base b of m times the log base b of n. So that's not how logarithms work. Just because this is a product doesn't mean that we multiply two separate logarithms. Notice it becomes a sum of two separate logarithms. Another really common mistake that I see is if you were moving the opposite way, because of course we can go from here to here. This property works both ways. If we're starting like this, a lot of people say, oh, this is just the log base b of m plus n. So that is not true. So if you have the sum of two logarithms, again, you can combine them into one by multiplying these values. So just be really careful that you're using the property correctly. Also note for these, the base of the logarithm must be the same if you're going to condense it. So notice these are all base b. Now for your quotient property, it's very similar, but instead of having a product, we now have a quotient here. So log base b of m divided by n. You can expand it into two separate logarithms by saying log base b of m minus log base b of n. So notice the number that was in the denominator becomes the negative logarithm. The number that was in the numerator becomes the positive one. Again, try to avoid these common mistakes when you're condensing or expanding. Again, the base must be the same. It's base b all the way across. All right, the next one is actually a really, really super useful property. It's called the power property of logarithms. And we're going to use this a lot when we're solving logarithmic equations. So here, if you have log base b of m to the power of n, logarithms have this really cool property where you can actually take that exponent n and you can actually just move it right out front. So it's the same as saying n times log base b of m. Of course, if you have a number out front here, we could also move it up here to the exponent. So we can use the property both ways. Now again, this only works for logarithms. No other time can you just take an exponent and move it out front. It only works for this power property of logarithms, but it is super useful. And then the last property, which you'll be using mostly so you can evaluate logarithms in your calculator, is the change of base property. So if you have log base c of a, you could rewrite this as the log of a over the log of c, and you can pick whatever base you want. So just so you guys know, for scientific calculators, most scientific calculators can only do common log or natural log. So if you're trying to get a decimal approximation for something, let's say like log base 2 of 7, okay, most scientific calculators, unless you have a really fancy one, cannot do log base 2. So you'd have to rewrite it using either common logs or natural logs. You can pick whichever one you want. So most often we'll just do common logs. So we would write that as the common log of 7 divided by the common log of 2. So notice this number goes to the logarithm on the top and your base goes to the bottom. So then this would be something that your calculator could evaluate for you. So this is going to be really useful and an important property to know if you're trying to get a decimal approximation for a logarithm. Okay, so now we're going to practice using these different properties of logarithms, and we're going to be taking two, or you could do more logarithms and express them as a single logarithm. So we're condensing. So let's look at this first one. We have log base 3 of 6 minus log base 3 of 18. This is going to be, we're going to use that quotient property because we have the difference. We're subtracting the difference of two logarithms. So we can rewrite this as a single logarithm, and the positive logarithm, that value goes to the numerator. The negative logarithm, that number goes to the denominator. So just notice a really common mistake. This is absolutely not equal to the log base 3 of 6 minus 18. It does not work like this. So don't do that. It's this, we have to use that quotient property. So now let's see if we can simplify. Well, we know that 6 over 18 is 1 over 3, and this we can actually evaluate. So remember, we're saying 3 to what power? If it helps, we can write it out. 3 to what power is 1/3? Oh, well, if it's just that reciprocal, we know that it must be -1. Remember, negative exponents flip your value. Okay, let's look at this next one. Here we have the sum of two logarithms. So remember, this is absolutely not equal to, don't fall into the trap, log base 5 of 1 over 25 plus 625. That's not how we condense. So we're going to use that product property. So it becomes the log base 5 of, we're going to multiply these two within a single logarithm. So 1 over 25 times 625. All right, so now let's keep simplifying. 625 divided by 25 is 25. So we have log base 5 of 25, and this we can evaluate. So we say 5 to what power is 25? Oh, 5 squared. So this logarithm is equal to 2. Okay, let's look at this last example. Here we have log base 4 of 64 cubed. So we can actually use that power property to make our life a little bit easier. Instead of actually cubing 64 to get some really large number, remember, we can take our exponent and we can move it out as a coefficient. So we can rewrite this as 3 times log base 4 of 64. So now we can evaluate. We can evaluate this part of our logarithm. So this part, we're essentially saying 4 to what power is 64? Oh, 4 cubed. So this 3 out front is still going to be there. And our logarithm, this logarithm is equal to 3. So we have 3 times 3, which is 9. And there you have it. So you can see how we were able to use our quotient property, our product property, and our power property to help us rewrite the logarithms, which helped us to simplify. All right, so at this point I'm going to ask you to pause the video and give these 3 problems a try. If you get stuck, just look at the last examples that we just did. All right, go ahead and check your answers here. So this first one, again, we use that quotient property. Remember, we rewrite it as a single logarithm, and it has a quotient within that logarithm. So it becomes log base 3 of 243, which is equal to 5. Here, this is our product property, so a single logarithm that we can rewrite using a product, 32 times 128, which is 4,096, and it turns out 4 to the power of 6 is 4,096. And then here we're using our power property. We move our exponent out front, and then we can simplify this logarithm. Remember, if the base and this result are the same, it will always simplify to 1, and then of course 8 times 1 is 8. Okay, now that we've seen how the basic properties work, we're going to try a couple more examples together. These are a little bit trickier. Okay, so let's look at this first one. We have log base 4/5 of 0.512 to the power of 6. So let's start with our power property. We can take this 6 and move it out front. Okay, whenever we're simplifying with a decimal, it might be useful here to rewrite this as a simplified fraction. So we know that 0.512 can be rewritten as 512 over 1,000, and then let's simplify that and see what we get. Okay, so here if we divide our numerator and denominator by 8, we actually get 64 over 125. So let's rewrite this as 6 times the log base 4/5 of 64 over 125. So again, anytime there's a decimal here, we're going to try rewriting it as a fraction to see if we can simplify. So let's see now if we can simplify this logarithm. So we have 4/5 to what power equals 64 over 125. Well, 4 cubed is 64, 5 cubed is 125, so it's actually 3. So we have 6 times 3, which is what the logarithm is equal to, which is 18. So you can see that something like this, it doesn't look like something that you could easily simplify by hand, but using our property and then rewriting our decimal as a fraction, we were able to simplify it pretty easily. All right, let's look at this next one. Here we can start by using our power property, so 6 times log base 5 of 1. This is one of those definition-based properties right here. Any base logarithm of 1 is always going to be 0, so 6 times 0 is 0. And let's look at this last example. All right, here we have log base 8 of 8 to the power of x plus 4, and then log base 2 of 512 to the power of 5. So we're going to try to simplify this as much as possible. So let's start by using the power property here. So we're going to take the entire exponent. I'll keep it in parentheses to show that it's grouped, and then times log base 8 of 8. And then plus, let's do that power property again, 5 times the log base 2 of 512. All right, so now let's see if we can simplify this. Remember, if the base and this number are the same, it always simplifies to 1. So we have x plus 4 times 1 plus 5 times. Here we're essentially asking ourselves 2 to what power is 512. We'll simplify this, and it's 2 to the power of 9. All right, so from here, x plus 4 times 1 is simply x plus 4 plus 45. So this we can simplify to x plus 49, and that's as much as we can do. Okay, here's the last 3 we're going to do together. So here we have the common log of log base 4 of 32 plus log base 4 of 2 all to the power of x. So let's start by looking at what's in here and seeing if we can condense this using that product property. So we have the common log of the log base 4 of, and remember, since it's a sum of two separate logarithms, we can condense it by taking the product of 32 and 2. So 32 times 2 is 64, and all of that is to the power of x. Now let's see if we can simplify this. We're saying 4 to what power is 64? Oh, it's 4 cubed. So that logarithm is actually just equal to 3. Okay, and then here we can use our power property and put x out front. And here, this is really as much as we can do because, by hand at least, so because this is a base 10, so it's just x times the log of 3, because 10 to what power is 3, it would be some decimal. So we could also, we have the option of plugging this into our calculator to get a decimal approximation, but to keep it exact, this is about as much as we can simplify. So this would be our final answer. Okay, let's look at this next one. Here we have log base 6 of 2,196 minus log base 6 of 3 plus log base 6 of 8. So we can actually condense this into a single logarithm using our product and quotient property. So here I'm going to write a single logarithm. So any number or any logarithm that's positive, these values will go in our numerator. So we have 2,196 times 8. We're adding them, so it's the product of those two numbers, and any negative logarithm that value goes to the denominator. So notice these two values, since they came from positive, logarithms go to the top. This value goes to the denominator. So now let's see what we get. So if we simplify within those parentheses, we get 5,856. So from here, again, there's no whole number answer where 6 to what power is this value, but we can rewrite it using our change of base formula with a common log. So if we needed to, we could plug it into our calculator. So we could rewrite this as common log of 5,856 divided by the common log of 6. So this would be our exact answer, or we could plug this into our calculator and get a decimal approximation. Just be careful here again. It doesn't matter what order your logarithms are written in. Anything positive will go in the numerator and be multiplied. Any logarithm that is negative, that value will be divided. Okay, and here's our last example. So log base 2x plus 5 is 4x squared plus 20x plus 25 to the power of 5. So this one looks really scary, but let's just try it together. So let's start by using our power property. Let's move that exponent of 5 out to the front. All right, so here I'm looking and I'm saying, well, I wonder if I can actually simplify this a little bit, maybe by factoring. So if you actually factor out 4x squared plus 20x plus 25, here's a good little review for us. I'll do that bottom up method that we used to do. Again, you can use whatever method you want. So remember, for the bottom up method, I temporarily multiply my a value to my c value. And then this you can factor to x plus 10 times x plus 10. But remember, since we multiplied by 4 at the beginning, we have to divide by 4 at the end, like this. Now both of these values can be simplified. So let's simplify it. X plus 5 halves times x plus 5 halves. And then we bring anything left in the bottom up. So 2x plus 5 squared. Same factor multiplied twice. So we can rewrite this as 5 times the log of base 2x plus 5 times 2x plus 5 squared. So here we can actually use that power property again. So this 2 will multiply out front, so it becomes 10 times the log base 2x plus 5 of 2x plus 5. And then notice Here we can actually evaluate this because our base and this value are the same, which means it should always simplify to 1. So 10 times 1 is simply 10. So something that looks really scary, like we shouldn't be able to simplify it by hand, we actually can by using our properties. All right, so that's all for today's video. Thank you so much for watching.